Let's humble ourselves for a word of prayer. Heavenly Father, we want to thank you for this day. We want to thank you for yet another opportunity you've given us, Father, to study. We dedicate this lesson into your hands. We pray that you guide us in each and everything. Help us understand what we are going to be taught so that it will help us in the future, Father. In the mighty name of Jesus Christ, I pray.
Amen.
Amen.
Thank you so much, Peace, for the word of prayer. You are most welcome, everyone. Thank you so much for joining and for being on time. So today we are going to look at differentiation 2, and we are continuing with differentiation of trigonometric functions. So I'm going to ask you in the chat to just remind me to just remind me, what do we obtain when we differentiate this? So just we are going to just do a quick reminder, because you know that under trigonometry, we looked at differentiating of sine x. So whatever I write, you put your answer in the chat. Members, when we differentiate sine, what do we get in the chat? A quick one. Just type in what you think your answer is when you differentiate sine. I'm seeing some answers. Good. Someone says cos, Ruth cos, Sarah cos, Gilbert cos. Very good. Members, what about when you differentiate cos? What do we have? When we differentiate cos, what do we have? When we differentiate cos, what do we have? Very good. When we differentiate cos, we get negative sign. Members, what about when we have tan? When we differentiate tan, what do we have? When we differentiate tan, some people are saying sec x, sec squared x. Remember now, some of these things are needed to be knowing them at your fingertips, such that you do not waste time whenever you find that. Okay, sec squared x. Members, what about when you differentiate sec x? When we differentiate sec x, what do we have? When we differentiate sec x, what do we have? When we differentiate sec x, what do we have? Very good. We have sec tan. Sec tan. Okay, very good. Then what about when we have cosec x? When we differentiate cosec x, what shall we have? What shall we have for cosec x? Cosec. What shall we have? Yes. K cosec. Negative cosec, cot. And then lastly, what about when we differentiate cot x? What about when we differentiate cot x? What about when we differentiate cot x? Thank you, Alvan. Okay. Very good. Now, these are the major trigonometric functions you must be having at your fingertips on how we differentiate. Do not forget for cot, you have James a negative cosec squared x. Now, after having those ones, it means that the rest of the things we are going to be dealing with, it's going to be just a matter of you going on to interact with the different approaches on how we differentiate. So we looked at this summary, and now we are going to build from here, and now we look at some scenarios where we apply the differentiation of trigonometric functions. And remember that under this topic, we are going to look at some of the applications of these trigonometric functions. Some of you have seen pendulum bobs swinging, you have seen oscillatory motion. Those are some of the physical applications that we shall be looking at. When you were still at nursery, you used to sit on those, there are some things we used to sit on. I don't remember even how they are called, whereby you sit here and then you keep on swinging left, right, Still, that is an oscillatory motion. And that one we can model it using trigonometry. Yes, so we are going to look at that as well. So those are some of the applications where we are going to find our word problems coming from. And we are going to look at the first one. Yes, so we are going to look at the first one from the physical world. Yes, so I'm going to ask you to read through. Yes, read through. Mm, Okay. They are telling us that we have a particle that is moving in a straight line in a such a way that its distance from a fixed point O t seconds after the motion begins is cos t plus cos 2t centimeters. Find the time when the particle first passes through O. Now, when you look at this kind of motion, there are certain things that I'm going to first summarize here for you to know it. Number one, whenever we are talking about the physical world, there are things that you need to know at your fingertips. Things such as distance, things such as displacement. Now, I want to bring, it does not matter whether you do physics or you don't, because this is application of trigonometry. We have some quantities. We have what we call distance. Distance is the length between 2 points. And then we have what we call displacement. Displacement is that distance that you move in a specified direction. So displacement is a vector quantity. Distance is a scalar quantity. You have what we call speed. Speed is the rate of change of distance. However, when we have speed, it is related to what we call velocity, and velocity is the rate of change of displacement. Then we have another term we call acceleration. Now, whenever we look at this physical world and we are molding particles, it means that these are some of the things you are going to look at. Like I've told you that when you look at this thing that swings left, right, you notice that it is going to move. There is going to be, even here, I can add on the time. You are going to check that there is a change in the time. There is a change in the speed that at first, when you push it, it will move at a very high, like the speed, it will be too much. But with the time, it's going to start slowing down, slowing down. So that means that there is a change in the speed. However, sometimes the direction through which you push someone also matters a lot. But also it's going to move through a given distance. Now, that kind of movement is going to be modeled, or we are going to be attempting it using distance, displacement, speed, velocity, time, and acceleration. So you're going to hear these words more so when it comes to modeling these ones. Now, when you look at this kind of motion that is modeled by cos t, cos 2t, it is mainly an oscillatory motion. And under oscillatory motion, I will give you an example. In case this is our particle, let me say I have, this is just a spring. I'm just assuming. And this is the origin where the spring is. Remember, for the spring, before you put in, you first measure where it is. Then when you place it on something, let me say you have placed on a mass of a body, what is going to happen that this string of yours, it's going to come here, it goes like it's going to be oscillating. It will move up, it will move down, it will move up, it will move down, up, down, until when it reaches this resting what? This resting position. Now, what is the question asking us? The question is asking us, at what time when the particle first passes O? Now you need to know that this is now our horizontal. This is like the starting point. You are going to ask yourself, at this point here, what was the distance that this particle had covered? What could be the distance? Remember, when this particle is oscillating, it goes, it comes back. It goes, it comes back. In case I'm letting it to the swing thing, it means that that is the point where you start pulling from and it goes. Like, let me say this is where you have pushed the person from. It goes and then it comes back. It goes and it comes back. So the question is asking, what was that time when the particle first passed this point where you started your swinging the thing from? And now that's what we are going to answer, or that's what we are going to be looking at. Now, from there, there is something else we need to know. Number two is that how do we represent? Now, when we are defining, whenever you find these physical quantities, represent them using different letters. Define. In most cases, displacement, we define it using S or sometimes R. When it comes to velocity, many times we use V, and acceleration, we use A. But to define, you say that let my time be t. Let my speed be any letter you have chosen, and let your distance be any letter. So sometimes here people prefer using D, here sometimes people prefer using S. But for whatever letter you want, it is okay to use. Now from the question, they have told us that t seconds after the motion begins. Now they have given us the starting, the motion, how the equation they use to mod the what? The motion. But now I want to bring three things at your exposure. One is what we call displacement, which I'm calling S. From displacement, I want to put here the velocity. And from velocity, I want to put what? Acceleration. Now, what do you need to know is that whenever they ask you these questions from the physical world, what do they want? Once they start with displacement, the next thing they can ask you can be velocity. From velocity, the next thing they can ask you can be acceleration. Alternatively, once they start from this side here, now when we are moving from displacement to velocity, from velocity to acceleration, here we go on differentiating. With respect to what? With respect to time. So whenever you are taking this side here, here we differentiate with respect to time. Then if you are moving from this side, coming this side, let me say they have given you acceleration, you want to obtain velocity, they have given you velocity, you want to obtain, this is where we integrate. But since we have not yet looked at the integration, I'm not going to talk about it. But here we integrate with respect to time. Now you need to know, what have they given us in the question? The question has given us displacement. That means that for whatever thing we are going to do, in case they give us displacement and they want us to find velocity, we are going to be able to differentiate displacement. In case they have given us velocity and we want to get acceleration, we differentiate what? Velocity. Alternatively, you can also go back and look at the definition that whenever they are talking about velocity, velocity means the change in the displacement with respect to time. So in case you are writing it in the differential format, we shall write this as ds dt. In case you are talking about acceleration, acceleration means the change in velocity with respect to the time. So in differential, we shall write this as dv dt. That's why now you need to, those words should be familiar. So now when you look at part B, when they ask us to find velocity, it means that to find velocity, I'll differentiate displacement with respect to time. In case for part C, they want us to find acceleration. Acceleration, I'll differentiate velocity with respect to time. So you notice that one part leads you to the other. One part leads you to the other. Kindly let me know in the chat. Are we on the same page? We are just breaking the question. We have not yet started, but tell me whether we're on the same page. Okay, 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 okay. Okay, okay, okay. I've gotten you now. Now, let us now start on this item. Now, we are going to say that let our displacement let our displacement be S. Now from here, our displacement S is given by cos t plus cos 2t. But they told us that everything is given in centimeters. Like I've told that this kind of motion is called an oscillatory motion, whereby we have your particle here and your particle, like this is our spring, and this is the origin before you have suspended on a given mass. So in case you suspend on a given mass like this, then this thing spring of yours is going to oscillate, it's going to go up like this. Now this one is what you call the rest position. Members, you let me know, we know very well that this one is what we call the y-axis. Members, if this is your resting position, what displacement do we have at this point for y? Tell me in the chat. Now I'm checking whether people are understanding something. What displacement shall we have at that point? Mick says 0, 0, 0. Very good, very good. Now members are understanding. So here we have 0. The moment it goes above this position where you started from, let me say it will be positive. It comes down below it, it is negative. It goes up, positive. It comes down, negative. But the moment it reaches, this is like the resting position. Now, members, that one is very key. Is very key now for part A because they're asking the time when the particle first passes through O, the fixed point. This is the fixed what? Point. So at fixed point, it means that the displacement of the particle at that point is 0. So I'm going to say that at the fixed point, our s with respect to time is equal to 0. It means that at that point, time is not equal to 0. Do not make it. It is the displacement because now it is at the resting position. Now what do we do? Where there is s, we shall substitute with 0. So we shall say, allow me to write 0 equals to cos of t plus cos of 2t. Alternatively, I can write it in this better way that cos of t plus cos of 2t is equal to 0. Members, hope we are still on the same page. We shouldn't leave you from that. We shouldn't leave you. But I've said that I want you to that point at 0. 0 is like the starting point where you have started. Like in case you are referring to this thing that it's called the what? This thing they swing, I don't know how it is called. That thing you swing is that the point where you push the person from, the point where you start to push the person from is what we call the rest position. So whenever the particle, like in case you are counting, you remember how you count, when it's called a seesaw. I don't know. That thing whereby they tie up here, then you come here, you sit here, and then someone will come, he pushes you, you go, you come back, like that, Now this, like remember when you are counting, it's called a swing, okay, a swing. Yeah, you remember when you are counting how many routes the person has gone. You'll count, he will first go, he comes back, you count 1. He goes, he comes back, you count 2. He goes, he comes back, 3. Yes, but the moment is real, he's at this point where you started from. That's where you start counting from. But at that point, it is 0 because that one is starting a new movement. Like when you are starting, this is you go, you come back. That is 1. So the moment the person reaches this point where you started from, that's when you count that now it has been a 1 route. You go, he comes back. Let me hope now it is clear. Hope it is clear. Why are we saying S is equal to? We said S is the displacement, is how the function has been, the motion, how the person is moving has been molded. Remember, whenever we have a cos is a curve that goes like this, like this, like this. So it shows you that it goes, it comes back. It goes up, it comes back. So that is the kind of model that the person has been able to get. Okay, yes, Queen. Let me first answer Queen and then we continue.
Good afternoon, teacher.
Yes, good afternoon.
So my question is, okay, we've equated that we've been told that a particle is moving in a straight line in such a way that its distance from a fixed point O is cos t plus cos 2t. But then we are equating that distance from a fixed point to the distance at the fixed point. Like where are we equating? Where are we saying 0 is equal to the other distance, yet 0 is at the fixed point and this distance is from the fixed point?
Let me just use this. Are you saying this?
Yes, teacher.
Now, our particle, let me say, this is your particle. Like I've told you, this is like an oscillatory motion. This is where your particle is. Now, when we are referring to displacement or to how the particle is moving, your movement in a straight line can be up and down, up and down. Is that fine?
Yes, teacher.
Now, when the particle is at this point here, the fixed point, what is its displacement? When you look at the y values,
0.
is 0. Now, S represents that motion. So sometimes they may use the letter Y. Sometimes they may use S. Sometimes they may use R. Are you getting it?
Yes, teacher.
Yeah. So the moment the particle passes here, its displacement Y is going to be 0. So that's why we are equating to 0, because they're asking us at this point when it passes through.
Okay.
It's fine?
Yes, teacher. Thank
Okay.
you.
Okay. Now from here, the next thing is going to be now solving using your trigonometric identities. When you look at this, you notice that we have cos t and cos 2t. And members, you cannot solve this kind of equation when you have a double angle here and then you have a single angle. So the first thing always you do, go and express it in terms of a single angle and then solve. And please do not do the other things of crossing. At this level, no. But let me just put this and maybe people may let me know whether we're on the same page. Do we know this identity, members? Let me know whether we are good to continue. If you know that identity, I'm going to just continue. Is that identity okay to everyone? Eh, yes, members are saying very good, very good. So that means that where there is cos 2t, we are going to replace it with that. So I will say cos t plus 2 cos squared t minus 1 is equal to 0. Now, when you look at this is a quadratic equation. Arrange it very well. So I can arrange it as 2 cos squared t plus cos t minus 1 is equal to 0. Now, at this point, it depends on how your teacher has taught you or which approach you use. So you can let me know through the chat which approach you use. You can solve it the way it is or by letting, by first saying that let cos of t equals to unknown, say m. And then after where there is cos 2, you substitute and say this is 2m squared plus m minus 1 is equal to 0. Is that fine to everyone? Or you have another? Okay, people are saying by letting cos. Very good. Members, can you go on and get for me the value of the unknown as I answer Edith? Yes, Edith.
Yes, good afternoon, sir.
Yes, good afternoon.
So some of us, we are not familiar with those identities. We are not fully done with trigonometry. So, don't know, can we have a summary of those identities?
Okay, can you first remind me, Edith, when I have cos of A plus B, when you expand, what do you get?
Yes.
Is
Is
that
it
from
cos
there? Cos A,
cos B
cos B,
minus sin A sin B? I'm not sure.
minus sin A sin B. You are correct. What about when I have cos A plus A? What shall we have here?
When the A's are the same.
Yes. Substitute the way you gave me that formula.
It is cos A minus sin A sin
Cos A minus sine of A, sine of A. What is cos A is the same as?
cos squared A.
Cos squared A minus sine squared.
Sin.
Okay,
Yes.
just a minute. Sorry, Edith, do you remember that?
That when you add sin squared and cos squared A, you get 1. Yes.
Yes. Now, since we are interested in writing in terms of cos, then I can say that sine squared A is equal to 1 minus cos squared of A. Now, where there is sine squared A, we shall put 1 minus cos squared A. So we end up with cos squared A minus 1 minus cos squared of A. So when you open, negative and negative will give you a positive. So you get something like 2 cos squared A minus 1 is equal to cos, but A plus A is the same as 2A. So that's how it comes about.
Okay.
Yeah.
Thank you.
Okay. But allow me to remove it now, but you can. Good enough you have seen. Okay. Now I'm looking through the chart. From the chart, people are telling me 0.5 and negative 0.5, negative 1, 0.5, negative 1. Members, me, I'm going to agree with everyone. So here I would just say that my M is equal to 0.5 and also my M is equal to negative 1. Now, after getting these values, members, you have not yet obtained the value of t. Go back and obtain it. So we are going to go back and obtain that angle, the time. So I'm going to say that cos of t is equal to a half. Then after I will say that t is going to equal to cos inverse of a half. Now, members in the chat, can you give me what is cos inverse of a half? What is cos inverse of a half? Now I'm going to check. Very good. Now I want to let you know that whenever, now what you have given me is degrees. You have given me 60 what? Degrees. But we are looking at time. So we are going to convert those 60 degrees into radians. So can we convert the 60 degrees such that you can give me that time in radians? Can you give me that time in radians now? I don't know that people are getting it. So I know you have got 60 degrees, but those are degrees. Remember, we are dealing with in time. We give it in radians. You cannot give it in terms of degrees. So that means in radians, we say that you get that angle of yours, multiply times pi, divide by 108. So that means that, thank you, Ruth. That means that by 0.06163. So that means that your t is going to be pi out of 3. Pi out of 3. Very good, very good. Now, from there, you check. Our time was given in seconds. Since it was given in seconds, I write here my seconds. And there is no need why I continue now to do what? So that is where I can end for now. When you check out when m is equal to negative 1, you may find out which angle you get. Yes. Yes, Irene.
Okay, sir, I would like to ask for more clarity on that last part how we get the seconds.
Or how we got the seconds. Have you been able to place cos inverse half?
Yes, I got 60 degrees.
Now 60 degrees is an angle, right?
Yes.
Now you convert it into radians. So to convert it into radians, you write it, you say pi, which is the angle, times pi divided by 180.
Okay, I got 21 out of 3.
Yes. So you get pi out of 3 seconds.
Okay, thank you.
Okay. Members, let me know through the chat whether part A is okay. I'm ignoring the second part because I'm not seeing that that one. Thank you, Samuel. Thank you, Samuel. Members, let me know through the chat whether now we can continue. Yes, Angel Miriam.
Good afternoon, sir.
Good afternoon.
Sir, for me, I've not understood where t is equal to pi out of 3s. Where
No,
you
this
got it
is,
from?
remember, we got our angle at 60 degrees. So we have to convert these 60 degrees into radians. And we said last time that to convert into radians, multiply this by pi, divide by 180. So this is 0 and the 0 cancels by 6, 1 by 6, 3. So you end up with pi out of 3. And remember, this is time. So I'll put it as seconds because the question specified that the time we have is in seconds.
Okay.
Okay.
Understood.
All
Thank
right.
you.
Okay. Yes, Akram. Okay, yes, Akram. Oh, sorry, Akram, come. Okay, okay. Another person, when you reach this stage here, another person, depending on how they taught you at your schools, another person could just come here and say that mathematically, this one I can write it as 2 cos of t minus 1, and then this can be cos of t plus 1 is equal to 0. Someone could write it like that. And then after you continue. So someone could write it like that and then you solve. Or you could let and then you continue. Okay. So yes, very good, Ruth. Thank you, Ruth. Yes, I remember last time I told you that whenever we are dealing with the trigonometry, what we have here is always in radians. Whatever you have here is in radian, unless when they have put degrees. Unless when they have put degrees. Another alternative thing someone would have done is that you could have converted your calculator in radians. That is the second alternative, whereby the moment you reach here where you're placing cos inverse, for you change your calculator into radians. That is the second alternative. Because your calculators are in degrees. So whatever answer you get is in degrees. But we say that in trigonometry, always the angle we have here is in radians, unless there is a degree that has been placed. So that's why we are converting. The alternative is change your calculator into radians. And once you change and place cos inverse of 0.5, you'll find that your time is going to be 1.04719. But the only disadvantage with this one is that your levels of accuracy are going to be low as time goes on. That's why now, once you have it in degrees, convert it and write here, such that your levels of accuracy are high. But someone who writes pi out of 3, it's the same thing as 1.0 out of 3. So pi out of 3 is the same thing as 1.0471. But another mistake sometimes we do that, you forget to take back your calculator in degrees, which means that for whatever thing you keep on doing, you're going to find that you get wrong answers. Now that is another mistake that sometimes we encounter, that why sometimes we don't tell you to convert to radians, you forget, and you'll find that you're going to keep on making calculations concerning trigonometry, and at the end you find that everything is not correct. Let me hope everything now is okay. Okay. Are we good to continue? Okay, perfect, perfect. Okay. Now we are going to continue. We are going to continue. Now, part B. Part B, allow me to clean the screen. I'm cleaning the whole screen. Yes, I've cleaned. Part B, they asked us that the velocity of the particle at this instant, meaning that they're asking us what was the velocity of the particle at that point, at that fixed point. That's what we are finding out. Now, like I've already told you that when you have the displacement, and you are interested in velocity, what do you need? From displacement to velocity, we always differentiate. And I've told you alternatively, you can say that velocity is the change in displacement, which here I've used as with respect to time. Now, what are you going to do? What we are going to do, we are going to differentiate our s. So in our past lesson, we looked at how we differentiate trigonometric functions. Can I have one person raise up the hand and you tell us what are we going to get? I have d dt of cos t plus cos of 2t. I want someone to raise up the hand and you differentiate for us. Who's ready to differentiate for us that? Remember, you differentiate in the video item. You are going to first differentiate. What do you get? Yes, star.
Yes, good afternoon, teacher.
Yes, good afternoon.
Yeah, if I'm to differentiate that equation, it should be sine t.
Sine t. Something is missing. Something is missing. When you differentiate,
negative sine t.
Negative sine t. Good.
That's negative sine 2t.
Negative.
Negative 2.
2. Good.
Sine 2t.
Sine 2t. Thank you. Thank you. So members, that is our differentiation. Thank you, Abu. Yes. So that is what you end up with. So please let me first allow you to digest a bit. Let me allow you to digest a bit. Okay, now we are going to continue. We are going to continue. Okay. Oh, why is it negative? Remember we said whenever you differentiate sign, you get a negative. Yes. Yes, Sharon.
Teacher, I would like to inquire about where the 2 came from, the negative 2.
The negative 2. Were you around for the other lesson?
Yes, teacher.
Hey, remember we said when you have y is equal to cos 2t, we say that first let this, right? You say
Yes.
u is equal to 2t, right?
Oh, yes, I've understood.
Okay, but first give me a brief now before you run out. What did we say? Which rule are we going to use now?
You're going to use du dt
Du dt.
is equal to 2.
Then here,
dy du
dy du.
is equal to negative sine u.
Good.
Then we shall say, is it dy dt is equal to dy du times du dt.
Okay.
Negative sine u times 2. Hence, the answer is negative 2 sine of u.
But what is your u?
My U is 2T.
Okay, thank you, Sharon. So, members who are asking, that's how the gentleman came up with that thing. Yeah. Okay. Yes, Linda? Okay. Now we are going to continue. Now, the next part, since they told us at that instant, we had 2. So we had that our t was equal to pi out of 3. Now, allow me, even I'm going to tell you now, because sometimes they may even ask you the velocity of the particle at that instant, and they tell you, they can even say, leave your answer in SADS. Hey, they can add that leave your answer in SADS. So I'm going to come here and say V is equal to negative sign. Where there is t, I'll put pi out of 3 minus 2 sine of 2 times pi out of 3. So here we shall have negative sine pi out of 3 minus 2 sine 2 pi out of 3. Now I'm going to just do it as side work. Members in the chat, you just place for me roughly, what is sine of pi out of 3? What is sine of pi out of 3? Which answer do you get? Because here now I know.
Sir,
Ruth,
excuse me.
yes, please.
There in part A, we use where we got our m was -1. There is no need of using that time.
The time?
Yeah, we got m was 1. Now, we just got on with t equals to 60, then we turned that 60 into radians. But what about the other -1?
Okay.
There is no need of getting that time also.
Okay. Thank you. I'm going to ask someone to tell us whether there is someone who knows why we considered only positive. Why did we consider only positive and we did not consider negative? Yes, Dr. Peace. Oh, I saw Peace with a hand up. Dr. Peace? Oh, okay. Yes, Ruth. Let me pick Ruth. Okay, yes, Ruth. Melissa, I'm coming. Don't worry.
I'm trying. I'm not sure though.
Okay.
That when we get the, let me see. When we use -1, we get getting radians. Okay, I was thinking because if when we use -1, it's like the opposite direction. I'm thinking at the time when the particle passes through O is a positive. In the way you illustrated, that's the logic I'm using. In the way you illustrated, that it first moves down, moves down, then comes back to that fixed point, then maybe slightly goes back up. So we consider, that's what I'm thinking, why we use negative what? Why we use -1? But I'm
Why
sure
we
there's
don't use
another.
-1?
Sorry, why we didn't use it? Yes.
Okay, thank you. Melissa?
I think it's because time can never be negative.
Okay, you think time can never be negative. Okay, thank you. Giant?
I think since they said after the motion, that means you consider positive. But if they said maybe before, that's when maybe you'd consider the negative.
Okay. Thank you. Let me look through the chat.
Teach
Okay.
another thing.
Okay.
When I get the cos inverse of -1, I have 180. So maybe because like 180 is a straight line angle and this is sort of like an oscillation. So for some reason, in our first passing through O, I don't think it's like a whatever. How can I say it? 180-degree movement.
Okay. Thank you. Yes, all what they have given is okay. All those reasons they have given, they are okay and they explain that concept. So that's why we do not have our time as a negative. Yes, whatever reason they had was really valid. Yeah. Okay. I don't know whether the person has picked. They have given you quite a lot of reasons, Linda? So it is up to you to pick any. Okay. So I was asking here, sine of pi out of 3. Now, some of you have good calculators. Which calculators can give you these things in SADS? Some of you, your calculators have not reached that extent. They have not, So for you, what you do, in case you don't have the other modern calculators, I know the modern calculators will give you your answers -3 out of 2. Then in case you are using the other ordinary ones, what do? You will come here and say that sine of pi out of 3. So what you do is first take back this thing into angles. You know that this is a cos of 60 degrees. Sorry, not cos. This is sine of 60. Then you go back to what we call the special angles, and 60 is a special angle. You know that 60 here, this is 2 and this is root of 3. And then you know that sine, in case I'm interested in pi out of 3, is equal to opposite out of hypotenuse. So this will be root 3 out of 2. That is the alternative that you can use. And therefore, you just come here where there is sign of this, you put negative, then you put that. Then when it comes to 2 pi out of 3, then still you can do the what? The same thing. You say, now what am I going to do? You can now still say that now I want sine of 2 pi out of 3. But I don't know whether members here can relate. There is something we have here. I'm just asking. I want to know to just check out whether people know it. Members, when I have this, let me say I have sine 2a. Okay. Let me not go there. Let me just ignore it. Yeah, but now when we go, let us just go directly. So when you have sine of 2 pi out of 3, members, I don't know which answer you are getting. Which answer are you getting for 2 pi out of 3? I'm just looking through the chat to see which answer you're getting. What if it is not a special angle? In case it's not a special angle, then just deal with it the way it is. Get those decimals. Yeah. Same answer, root 3 out of 4. Okay, root 3 out of 4. Members, do you have that? Do you have root 3 out of 4? Others have 2.9. Remember, we are leaving our answer in SADS. We are leaving our answer in SADS. Okay. -2 root 3. I'm having root 3 out of 2. Okay. Yes, Maria.
Good afternoon, sir.
Yes, good afternoon.
Can you please repeat on how to get negative root 3 out of 2?
Okay, I'm going to throw some. Do you remember special angles?
Yes.
You remember 60. And remember we
Yes.
said we use an equilateral. This is 2, this is 1, this is root 3, right?
Yes.
Now, sine of 60 is just the opposite out of hypotenuse, which is root 3 out of 2. Is that okay? Okay, hope that is okay. Members are getting some answers, but I want members to agree with me that you shall get 2 root of 3 out of 2. Sine of 2 pi out of 3 is the same as root 3 out of 2. Please confirm from your calculators whether it is true or false. Is it the same, root 3 out of 2, or we are getting something different? That's what I'm getting here. True. Yes, now, it is true, Ella. The same. Yeah, now how do we get it? Now, like I've told you that one, those people who have the other modern calculators, for you what you do, get this one, put it on your calculator. When your calculator is in radians, you'll get the answer directly. But in case you do not have it, for you what you do, you are going to first do 2 pi out of 3, that is the angle. So this will give you 2 times your pi out of 3. Then you can say, what am I going to do? This is the same as 2 times pi out of 3. This is like 180 out of 3. And it will give you 120. Now you ask yourself, what is sine of 120? Now here you are in degrees because you have converted from radians to degrees. And then you go on your calculator. What is sine of 120? Sine of 120, you'll find that your answer is root 3 out of 2. Or your calc may give you 0.866025, something like that. Yeah, so that's how you obtain it. Okay. So that's how we have obtained it. So from here, we are going to collect like terms. So you see this 2 and the 2, that is like the LCM. Then here you remember your SADs from your knowledge of SADs. Now that's the one that we are going to be applying. So from your SADs here, you notice that our LCM is 2. Here I have negative 3 minus 2 root of 3. So here there is an hidden 1. So negative 1 minus 2 will give us negative 3 root of 3 out of 2. And therefore, I'll come here and I just conclude that our velocity is equal to negative 3 root of 3 out of 2. And then I take note of units that these are centimeters. And this being velocity, we said velocity, these were centimeters and these were seconds. So I'll say this is centimeters per second. Or you can write centimeters per second. And now that's where our velocity of the particle at that instant will be. Yeah. Okay. Members, hope we are on the same page with that. How do you change? We say that when you are changing to radians, when you are changing from radians to degrees, your pi is the same as 180. So where you have pi, multiply times 180. Okay, let me pick a hand. Yes, Lydian.
Teacher, why do we have to change from degrees to radians?
No, degrees to radians, why I'm doing so, one is that for some of you, your calculators are not able to give you a direct SAD. But if your calculator can give you a direct SAD by inserting it the way it is, then it is very okay. Go on and continue.
All right, thank you.
I don't know. If someone has that calc, kindly, you take a screenshot and show members. Take a screenshot Now, maybe let me as well take you through this trigonometry, how that thing comes about. Now, you remember very well when you are dealing with trigonometry, when you check 120 degrees, like the angle you have obtained here is 120 degrees. You remember very well. So this is 180. You know that in this quadrant, you have all S, T, and C. Now, in this second quadrant, sign is positive, meaning that any acute angle in this quadrant, the angle you have here is going to be 180 minus 120. And when you check out 180 minus 120, you end up with 60 degrees. So what does it mean? It means that sine of 120 is the same thing as sine of 60 degrees. So that's why we have sine 120 is the same thing like sine of 60. In case you want, you can interpret it in that format. Yeah. Yes, Allen.
Good afternoon, sir.
Yes, good afternoon.
I have a question. Is it a must, like, okay, is it a must to leave your answer in SADS?
Oh, no, not really, but just because here in the question, I restricted it. I said, leave your answer in SADS. So I wanted you to check out that in case they tell you to leave in SADS, then this is how you'd have approached it. But in case it is general, then give your answer. It is okay to give your answer in points.
Okay. Thank you, sir.
Okay. Okay, members, let me know through the chat whether we can continue now. I think that is the calc. African giant, yes, that is the calc. There's another calc which has a green thing as well. So when you are buying calculators to use, if you want those ones that simplify the work, you buy those types. They can make your work. Yes. Yes. Is our answer negative? Yes, our answer is negative because remember, velocity will look at the direction. So velocity can be negative. What can't be negative is speed. Yes, but velocity can be negative. Yeah. And the negative now here, even they can ask you to interpret. So the negative shows you that, like, you know very well that when you are pushing this swing, it goes at first, it will go with a lot of energy. But as time comes on, the energy keeps on reducing. So like your speed keeps on reducing. So the negative is like showing you that the speed or the velocity keeps on changing. Okay, why don't you allow me that now we continue to the next part. I'm going to clean the board. In case you have not yet finished writing, take a screenshot, but I'm cleaning now. Now, part 3. Part 3, they ask us that the acceleration when the velocity is 0. Now, we have obtained our velocity. Our velocity was what? Was negative. Our velocity was negative sine t minus 2 sine 2t. But they have told us that what is the acceleration when the velocity is 0? What does it mean? We have two things here to deal with. We are going to ask ourselves, at what time is that when our velocity is 0? This is the velocity. Then after finding that time, we are going to go on and find the acceleration. And see now what is our acceleration, such that the values we obtain for t can be substituted here. So the first thing we are going to obtain that at what time is it when the velocity is 0. So we shall say when v is equal to 0. So where there is v, we shall put 0. So we shall say 0 is equal to negative sine of t minus 2 sine of 2t. Now, the moment you reach here, the first thing you need to know is that you cannot deal with these angles when you have t and you have 2t. You cannot deal with that. So the first thing you always do, first take it into a simpler form. Now, the first one I'm going to ask you, members, you tell me, what kind of identity do you remember when we have sine 2t? Which identity is that can expand for us to get a single angle? what is sine 2t equaling to? Remember now we are applying trigonometry. Apply. What is that identity we can apply at that point? Double angle identity. Thank you, Paul. Can we expand it? Perfect. I've seen some answers in the chat. So when we have sine of 2t is the same as sine of 2t cos of t. That means that where we have sine 2t, thank you, members. The answers are correct. So where you have sine 2t, you are going to substitute with this. So you will come here. Where there is sine 2t, you substitute that. So I'm going to write this as negative sine of t minus 2 sine of t cos of t equals to 0. Yes, that is the first thing. Never solve these equations when you have like a double angle, maybe 3 angles, unless when the angles resemble. If everything here was 2t, that is okay. But if the angles are different, then look out for the approach that brings them to either a single angle or to an angle that makes them the same. Let me pause there and I first ask people to be solving as I take on some few hands, but also as I check on the people on the call. Yes, Abu, hope we are on the same. Yes, Alvan.
Teacher, my question is, can't we just differentiate from that step 1 and we don't go breaking it down?
Alvan, come again. Don't mute.
Okay.
Can't we just differentiate?
Okay, yes.
Now,
so
Alvan.
as to get the yes, teacher.
As to get?
So as to get the one for acceleration.
Oh, you are very correct. So what we are thinking is for acceleration, and we have not yet obtained for acceleration, but I've started with this part where they are telling us where the velocity is 0. So that means that when the velocity is 0, it does not mean acceleration is 0. True, false? I want to talk with Alvan, but I don't know. Alvan, don't mute.
Oh, okay, sorry. Yes, it's true, teacher.
It is true. So here we have to break our item into 2. We are going to find out, because remember acceleration, when you look here, when you differentiate, you notice that we shall have an element of time. Have you seen it?
Yes. Yes, teacher.
Now that time is what we don't have. We don't know at what time was it when our velocity was 0. So the first part, why A? So have you understood?
Okay. Yes, teacher.
First
Thank
explain
you
to us
very
what
much.
you have understood. First explain to us a bit.
Okay, teacher, what I've understood is we have to first get the time when the velocity was 0, so as to, I think, substitute in the other expression we shall get later. Because here the question is the acceleration when the velocity is 0. But then we don't have the time when the velocity was 0, so we have to first get that one.
Okay.
That's what I've understood.
Okay, thank you. So let's be calculating that time as I pick on more 2 hands. Linda?
So, 0 is equal to 9 in 2 sin t.
You're saying?
Here I have said sin 2t is equal to 2 sin cos t. Not so. So,
yes.
And that sin t minus 2. Getting me, sir?
No, I'm not getting you. I'm not getting you clearly.
But the other 2 what I'm trying to tell you is there is a 2
Oh, okay.
Yeah.
These two here. Okay. Okay, I've seen it. Okay. Okay, thank you, Linda. I've seen the two you. Okay. Thank you. Uh-huh. Juliet, hope members have seen the two, eh? There is this two here that I think I forgot to carry here. Yes, Juliet?
Good afternoon, sir.
Good afternoon.
So I'm requesting for pardon on that part where you say that 0 is equal to negative sine t minus 2 sine 2t. Then the continuation part.
Okay. Okay. Now, Juliet, was that part okay, the first one we wrote?
Yes.
Uh-huh. Now, where there is v here is where we are putting the 0. So that means we shall have 0 equals to negative sine t minus 2 sine of 2t. Is that fine?
Yes.
Now, we have an identity that whenever I have sine of 2t and I expand it is the same as 2 sine of t cos of t. From your trigonometry, do you know that?
I'm going to check it out.
You're going to check it out. But it also comes from here where we have sine of a plus b. Then you say this is sine of a cos of b plus sine of b cos of a. You remember that?
Yes.
So when I have t plus t, what do you end up with?
Sine t cos t
Uh-huh.
plus t cos t.
Uh-huh. So when you see sine t cos t, when you add those two, are you noticing they are the same?
Yes.
So when you add, what do you get?
2 sine t cos t.
Uh-huh. So that's where it comes from. So here t plus t gives you 2t.
T.
Then now you get it and you substitute here. Where you have sine 2t, you substitute that. So
yes.
So that is 0 equals to negative sine of t minus the 2 into 2 sine of t cos of t. Hope that is okay now.
Yes. Thank you, sir.
Okay, don't go off now. Stay on. Continue for us from here.
So we get negative sine t minus 4 sine t cos t.
Okay, good. Tell me what is common here and here and factorize it for us.
So we remove negative sine t.
Okay. What do we get?
Into 1 minus 4 cos t. No, we get 1 plus 4 cos t.
4 cos of t. Okay, good. So how can we now go from here?
I don't know. I think I can just stop that.
Okay, what if you have this? How do you move from here? Okay, I start from here. X minus 2, x plus 3. How do you solve this?
We multiply x.
We are
X into
solving.
bracket.
I want the value of x.
The value of x.
How do you solve this quadratic equation here from this point? You have finished factorizing what? So how do we go from here?
So we say that
Either
x minus 2 is equal to 0 or x plus 2 is equal to 0. X
apply the
plus 3
same
is,
concept here. That is
so
correct.
here negative sine t is equal to 0
Okay.
or 1 plus 4 cos t is equal to 0.
Okay. Good. Can we solve this?
Are we going to? No.
We can remove the negative first.
We divide both sides by -1.
So we remain with sine t is equal to?
0.
Then we set t is equal to sine inverse of?
0.
Can you now give us the angles? Now here, members, you first exhaust all the angles. What are some of those angles that give you sine inverse of 0?
So sine inverse of 0, I'm getting 0. 180.
What is, now remember here, don't forget I told you here we give in pi. So give us in pi.
Pi.
Okay, pi. Which other can we have?
I think there are those ones.
We have
Can we
other
put 300?
angles. Yes, 360. It gives you what? 2 pi.
306. Yeah, 2 pi.
Okay. Then we go this side as well and we solve.
So here I get 4 cos t is equal to -1. So I divide both sides by 4.
So you get?
T is equal to cos inverse -1 out of 4.
Okay, so we end up with?
The angle I'm getting 100.47.
100?
4.47.
104.7.
Yes.
Okay. Let me first leave it at that. We shall come back there. Okay.
Okay.
Okay, thank you. Yes, Bahati.
So good afternoon. My question is, how did that come from negative sine t minus 4 sine t cos t to negative sine t into bracket 1 plus 4 cos t?
Are you seeing this negative?
Yes.
Are you not seeing there is an hidden one here?
Yes.
So
I'm
here,
seeing.
there is a common factor of -1 and a negative here, right?
Yes.
It is what we have pulled out. It's what we have pulled out. Then sine is here and sine is here. So we have also pulled it out. Are you seeing it? So when we pull out this, here
Thank you,
we
sir.
remain with 1.
Yes.
And here we remain with cos. Okay, Bahati.
Oh.
Yes, Ruth.
Thank you, sir.
Okay,
Teacher, my
Bahati.
question is, do they give us limits for these questions? Because or we just know that it's 0 to 360.
Now, here they may not give you the limits, but from your thinking, you may know that what is a full cycle? That a full cycle goes up to how many degrees?
360.
360. Yes. But in case you are lucky and they have given you like a limit, then it is okay. The range. But in case they have not given you that range, then better obtain as many angles as you can and then put all those angles.
Okay, thank you.
Okay. Okay, now members, I wanted to see how I can have this because I want to create another screen, but let me see whether it will be possible. Hope my work will not disappear. Okay, I want to go to the second part of acceleration. Remember, we have only found one part Now we are going to the actual part of acceleration. That means here it has showed us that at that point, acceleration is 0. And now members, if I show you okay, I will show you the graphical approach, just the graphical representation. Now we had our velocity. Let me use another color. Okay, let me use black. So we had negative sine of t minus 2 sine of 2t. Now remember we said that to get our acceleration, we shall have our velocity with respect to time. Can I have a volunteer to differentiate for us to get velocity? Who wants to do for us that? Okay, Ruth.
Okay, so negative sine t is the same as cos t.
Okay, just a minute. So what are we going to have?
It's equal to cos t
Cos
minus,
t. What
yes,
about this negative, Ruth? Is it disappearing? Oh,
it's disappearing.
why?
Why? Because when we differentiate cos t, I get a negative sine t. But when I
What are we
differentiate,
Ruth, are you saying what we are differentiating?
yes, yes, it doesn't disappear, does it? Doesn't.
Okay, so what shall we have?
Negative cos t.
Negative cos t.
That minus 4 cos 2t.
Minus 4 cos 2t. Thank you, Ruth. Now, members, what are we going to do? Now, at this point, what we are going to do is that this is our acceleration, but they wanted when the velocity is 0. So we have obtained our values for different times when the velocity is 0. So we are going to substitute them in. So what we are going to do, we are going to say that for all the times, for t equals to 0, I substitute, I'll get my answer. So I'll say A is equal to negative cos of 0 minus 4 cos of 2 times 0. So this will be negative, okay, you fill in, eh? So here I'm going to get negative 1 minus 4, which will give me negative 5. Then after that, you can say, when my t is equal to pi, then you come and say my A will equal to negative cos of pi minus 4 cos of 2 pi. Yes, be putting them in your calculators and we see what we have. Be putting them in your calculators and then do not forget now here, the moment you have pi, yes. I don't know which answer you get when you put in the pi. In case you are dealing with these normal calculators of ours, when you put in your pi, make sure your calc is in radians. When you are substituting in pi, yes, that is the calc. That is the calc, that calc with the green thing. Thank you, Ri. Yes, yes, Jamie, you are right. Jamie, you are right. When you have cos t is equal to negative quarter, it shows you where the angle is, that angle is negative. So that means that it is in which quadrant? It's going to be in the second quadrant. It's going to be in the third quadrant. But we are going to deal with that as well. As a value of 2. Mary, we said, how did we get the pi? We say that you need to know the different angles. Like you need to go back to your quadrant. When you get your angle, your acute angle is 0, you go back and ask yourself, where does this thing give you? That here is all S, T, and this C. So in which quadrant is sine t equals to 0? Or where does it give you that? That sine can be here, 0. When I rotate, also at this point is 0. When I come back to the original point, also that one is 0. So you need to know how those quadrants work. In this quadrant, we said you get 180 minus theta. So your first angle, what we call the reference angle, is 0. So to get the next angle, you say 180 minus the reference angle. That is trigonometry. why the term is being multiplied by 0. Here, do not make assumptions. Place it on your calculator. Cos of 0 is 1. So negative 1 will appear. Cos of 0 is 1. So you get negative 4 times 1, which is negative 4. Yeah. So here, I don't know whether members are getting negative 3. Me, that's what I'm getting there. Thank you, Dr. Peace. I think. Patricia, let me hope. The term, no, it is the angle, Patricia, being multiplied by 0, not the whole of cos. Remember that T represents the angle. It does not represent that everything is multiplied. So don't, hope Patricia, that is okay. Negative. T is equal to pi is equal to negative 3. Okay. Then after, go on and put in the 2 pi. What do you get? Yes, Edith. Edith?
Master, on that t is equal to pi, how have you got it?
Do you know how to obtain other angles after obtaining the reference angle?
No.
Because hope you learned about this quadrant that all here we have sine, we have tan, we have cos. Let me say you have your sine of maybe theta equals to maybe let me say a half. I'm just using. This one shows you that sine is positive because a half is positive. That means you must get all the angles whose value of theta will give you a positive a half. And the first thing you look out is the quadrant. Where is sine positive? That sine is positive here and sine is positive here. Now, the first acute angle you get is always the reference angle. So when I place sine inverse over half, I'll end up with when you place sine inverse of 0.5, you end up with 30 degrees. That means that 30 degrees is the angle here. So to get the second angle in this quadrant that gives you the same sine, you get here, the angle from here up to here. But that angle can be obtained by saying 180 minus theta. So you say 180 minus theta, which is 30, you get 150. So when you place sine of 150, you still get a half. So that's how you obtain other angles. Is that okay?
Then on the answer, negative 3. On acceleration, the answer of negative 3, that one.
You just place in your calculator where there is t, put pi. When you place negative cos pi, you'll see that cos of 180 is negative 1. So here, you are going to, here you just place your calc. There's no need. Here I know you are going to get negative 1. Here it's going to be minus 4. Then when you place cos of this one, you'll get that. Negative 4 cos of 2 pi. I don't know whether it is okay or not yet.
Not yet, master.
Okay, which part is not yet okay?
This one of negative cos pi minus 4 cos 2 pi.
Okay, we'll come back here. When you place this in your calculator, what do you get? Place it the way it is. What do you get?
I get negative 4. Negative 7.
Negative cos pi minus 4 cos 2 pi.
Yes, negative 4.97446.
Is your calculator in radians or not?
Not.
Because cos pi is going to give you negative 1. Minus 4 cos of 2 pi is going to give you a 1. Is your calculator in radians or not?
Now it is in radians.
Then place again. And when you are placing, you place pi, like the way it is on the calculator. Press
Yes.
shift pi.
Yes, I've got the answer.
Okay.
As negative.
Okay.
Thank you,
Now,
Master.
those who are Karen, check out cos of pi is -1. So -1 times -1 gives you 1. For 2 pi, people are getting -5. Sendagile, when you differentiate sign, you get a cos, a positive cos. So there is a -4 cos of 2t. Sendagile. That negative doesn't appear. It remains there. For negative, a is equal to -5 for 2 pi. For 2 pi, that's what people are getting. Okay, for 2 pi, people are getting -5. Okay. Then what about for this last one? What shall we have? Now, for the last one, we have cos t is equal to -1/4. Now, I want to use the mathematics. Now, for me, I'm going to just summarize it in this way. When I look at my acceleration, I have negative cos of t minus 4 cos of 2t. So what can I do? I know that cos of t is the same as -1/4. So where there is cos of t, I can just substitute -1/4. If I don't want to go in those things of putting points, so I know this is negative times -1/4 minus 4. Now, unfortunately, this is cos of 2t. Now, cos of 2t, yet I have cos of t. It means that I can first write my cos of 2t in terms of a single angle. And what is cos of 2t? You know that cos of 2t in terms of t, in terms of a single angle, is the same as 2 cos squared t minus 1. Now, where I have cos squared t, I can say this is 2 times -1/4 squared minus 1, which will give me 2 times -1/4 squared gives me 1 out of 16 minus 1. Then I say by 2, 1, by 2, by 2, what do we get? That is 8. So I end up with 1 out of 8 minus 1. So then I say, what is 1 out of 8 minus 1? That it is -7 out of 8. So here I can just put here -7 out of 8. So then I say negative times negative, I get 1/4. Negative times negative, I get 4. Okay, even here I can say by 4, 1, by 4, 2. So I end up with 7 out of 2. So when I have 1/4 plus 7 out of 2, I end up with my answer is 3/4. And that's my value of A. I don't know whether we are on the same page, but I've tried to show you how you can do it. But alternatively, you can write it. In case you're using the other modern calculators, I know it may not give you a decimal point. But in case you want, you can deal with it that way. Yeah. And that one makes your work a bit much easier. So that's why I didn't want to get the angle. Yes, the moment, Patricia, you're dealing with the pies, your calculator should be in radians. Yeah. Okay. So let me hope we have been able to pick something from there. So, but we have not yet concluded. Can I conclude? So now in my conclusion, I'm going to say that my acceleration, I don't want to, okay, let me remove this. So I'm going to come and I say that my acceleration, therefore, I'll have, we had our answer. We had -5, we had -3, but also we have had 3 and 3/4. So remember the units, since they gave us in centimeters, so I expect this to be centimeters squared, because remember, okay, Then I want to put the units. This is negative. Now you remember you have acceleration is velocity out of time. So this was in centimeter per second out of seconds. So that means that you'll have centimeters squared. Centimeter per squared. So this will be centimeter per squared, centimeters per squared, and centimeters per squared. Now, in case you are visualizing it, acceleration means the rate at which velocity keeps on changing. Now, when you find acceleration being negative, it is an implication that it was decelerating. That is the point when the velocity was reducing. Then when you find positive, that's when it was increasing. Let me say from the start, when you push with a lot of energy, your velocity increases up to when it reaches the maximum. Then with the time, it keeps on reducing. Okay, I want to take on just one question. Yes, Sharon. Yes, Sharon. Okay, I'll fail to get Sharon. Yes, Bahati.
So what does it mean when the velocity is negative? What does it imply?
Okay, now, do you know what velocity is? Do you know what velocity is? Okay, now, velocity means the rate at which distance changes with time. Now, a negative velocity shows you that you are moving in a direction opposite. Take an example. I'll give you an example. When we have a velocity that is negative, let me say this was your intent. You are moving towards the east. When we are moving towards the east, that is like a positive direction. Now, when we have, okay. Let me not first bring in that concept. Anyone who wants to first answer him? Anyone who wants to first answer him? What it means for the velocity to be negative before I come in? Okay. Yes, Lillian. Oh, Lillian. Okay, I think. Okay. Yes, Jonathan?
Yes, teacher, I think that the negative, you are displaced in a negative direction.
Okay. You are displaced in a negative direction. Okay, thank you. So, that is very correct. So, whenever the position of an object is changing in a direction opposite to the initial one, then we shall say that is negative velocity. I'll give you a point that when I'm swinging, you remember that when you are swinging, when I push you, let me say, when I push you like this, that direction is going to be positive because that is the direction that I have used to push you. So that one I consider it as a positive direction. So that means that my velocity is going to be increasing. Like your speed is increasing in a particular direction. But when I'm coming back, your speed is reducing in opposite direction. So that change in the direction and the reduction in the velocity in the opposite direction is what you call the negative velocity. So that negative just means a change in the direction, the change in the direction in which you were moving. Or it can even mean an opposite direction. In case you are referring to time, you can say a decrease in the variation. Yeah. Okay. Yes, Trevor. I want to put another scenario.
So, like what you're trying to say is the velocity moves according to like the clockwise movement, of a body. When it's going in a clockwise direction, it's gonna be positive. And when it's going in an anti-clockwise direction, it's gonna be negative.
Somehow, but not really. What I am trying to mean is that it is you who determines which direction is going to be my positive and which one is going to be my negative. So, Trevor, if I push it like this, I can say this, I will say this is my positive direction for velocity. But when it is coming back, it is opposing the motion. Are you noticing? It is opposing the motion. So this is going to be a negative. Are you getting the difference? That negative means an opposition in the motion. Whenever you oppose the direction, it means that you put a negative. That means that your velocity is decreasing. Hope that is okay. That is okay. That's my assumption. Yeah. Okay. Now, members, should we look at another scenario? Let me know in the chat whether now we can look at another scenario. The units for accelerations are meters per second squared. But according to what we had, since we are dealing in centimeters, it will be centimeters per second squared. According to the chart, members are saying we'll look at another scenario. Okay, there we go. First read. Some of you, I know you have, I don't know even they call it. I don't have seen some people who put like tattoos on their bodies. But here, I don't know, there's something they use. But when we are talking about in terms of machines or in metals, so we call it etching, I think. Like when you are putting designs, you have seen like sometimes like when you are putting things on, let me say you have your metallic cup and you want to put something on your cup, there are some kind of machines we use. And when those machines are moving, they so they forms those kind of trigonometric curves. And now that's where we are getting that. When they are designing those names, they form those kind of curves. So we are going to start here. Now, when you look at our scenario, they are telling us that a machine at a fabrication workshop, they are trying to design something on a plate. Like the way you see this picture, I was trying to show you that kind of picture. And they have got two equations. They have got the X and they have got the Y. Now, here, when you are visualizing, you need to know that when the machine is moving, it has the X direction. This is the X, and it has the Y what? The Y direction. But velocity is a vector quantity. Being a vector quantity, we write it in terms of 1, its displacement, and 2, we write it in terms of its displacement. And its displacement is given in I and J notation. Whenever they tell you velocity vector, that means that you are going to write it in a vector form. And here we have two directions, the I and the J. That means that when when the machine goes up, it's moving the Y. When it does like this, so there is some X and Y, X and Y, X and Y movement. Now, in our velocity format, we are going to find what is the velocity in the I component and what is the velocity in the J component. So that's what we are going to do. Now, you need now to remember what we have is displacement. X is equal to cos 3t is the displacement. Y is equal to cos 2t is the displacement. Y is in the Y direction. X is in the J direction. So what are we going to do? Now we know very that in order for us to obtain velocity, we always differentiate the displacement. So I'm going to first say that my X is equal to 2 cos of 3t. But here they used X, so I'm going to define my velocity within the X direction as dx dt. Then I'll define the one for y as y is equal to cos of 2t. So here I will say that my velocity along the y is going to be my dy dt. Now, when they ask you for the dy, when they ask you for velocity, here they are indirectly asking at what speed does the machine work on? That's what they want to find out. That if you have this kind of machine, at what speed does it work? Because when you are working, at the moment when you go to those uniform centers, you go to those centers, you find them having those machines that put badges, that put what. So in case you want to find out at what speed, because many times people will tell you, this machine is very fast. But how do you determine how fast a machine is? By using these trigonometric functions. So can we have a volunteer to differentiate for us this function? What is d dt of 2 cos of 3t? Who's coming to differentiate for us that? Anyone? Okay. Melissa?
It's negative 6 sine 3t.
Negative 6 sine 3t. Very good. Melissa? Okay. Wafula, come back. Wafula, come back. I don't know that. Okay. Okay. Melissa, let's go on and okay. Okay. Dr. Peace.
Okay.
Take us through the second one for VY.
One for dy dt to be negative 2 sine of 3t.
Very good. Thank you, Dr. Peace. Now, those are our vector components for velocity in the I and then the J. Now, since they want the velocity vector, so I'm going to come and I say now, our velocity vector will be Vx within the I plus Vy within the J. So here I'm going to substitute our Vx as negative 6 sine of 3t I minus 2 sine of 2t of J. Now, this is when we still have the t, but since they have given us our t as 4.1, we are going to substitute now. Now, when you are substituting here, make sure that your calculator is in radians. So we are going to say 4t is equal to 4.1. Then where there is t, put 4.1. So I'll say this is negative 6 sine. Here I'll have 3 times 4.1 I minus 2 sine of 2 times 4.1 of J. Members, put on your calculator and put for me the answer in the chat, what you have for I and what you have for J component. Put your answers and put them in the chat, and then we see what we have. Here we are testing. Do we know how to place our calculators? Because it is important. You may lose some marks because you don't know how to place the calculator. Okay, when you get an answer, place it in the chat and then we see whether the answers agree with your friends. People are getting 1.58. May I recommend that whenever you are continuing to use that answer, write to 4 decimal places, at least 4 decimal places. That one improves on your accuracy levels. Trigonometric functions, write to 4 decimal places or even beyond. Don't round off. That one we call it pre. Okay. So I'm seeing some answers. In case you are not getting those answers, then that is an indicator something is not right, something is not working out. So we may need to support you such that you get the same answer. Pressing the calculator is also a skill. It's also a skill we need to learn. Yeah, place your calculators. I'm seeing some answers coming in the chat. In case that's not what you are getting, then something is not right. Something is not working out. Something is not working out. Shalom, if you could tell us where the problem is. Shalom, shalom, shalom. Is it Shalom or it was Sharon? One of you can unmute.
Yes, teacher. I've
Yes.
been I'm confused on how to put the work into the calculator.
Which calc do you have? Do you have these normal ones of 991?
Yes, 991.
Go to mode. Are you there on mode?
Yes, teacher.
What do you get when you place it?
I have comp and complex.
Continue placing. What do you have?
SD, reg, and base.
Continue placing. What do you
I
have?
have equation, matrix, and VCT.
Continue placing. What do you have?
Degree, radian, and
Place the radians, number 2. We are
and
there?
then press. Yes, teacher.
Now, we are placing -6 here. -6. Are you there?
Yes. Yes, teacher.
Sine. We are there?
Yes. Yes, teacher.
Open a bracket. Put a bracket.
Yes, teacher.
Place 3 times 4.1. Cross your bracket and place equals. Which answer do you have?
I have 1.5794.
Okay. Now you can remove and place for us the second one, this part here, and tell us what you have.
Yes. Should I include the negative as well?
It is okay. It is okay.
I have negative 1.8815.
15J. Yeah, so that's how you place it, Sharon.
Okay, thank you so much, teacher.
Okay. Angela, when do we know that our calculators must be in radians? I told you, and we said that whenever you find this angle, when you are not seeing degrees, your calculator must operate in radians. However, don't make a mistake. After placing your things in radians, run very fast and remove it. So to remove it, those who are using these normal calculators, press Shift, Mod 3 equals, and reset your calc. Okay, so members, for this is where we are going to end for velocity. And then the next thing we are going to do, we are going to put the units, that these are centimeters. So I'll come here, put a bracket and say centimeters per second. Okay, yes, Manuela. Okay, Manuela, I think it is sorted. Okay, so that's how you had to answer part A. Now, after part A, they told you hence. Whenever you hear the word hence, it means that from the previous answer you have been able to obtain, continue from there. Don't do any other thing. Continue from where you have ended and then continue. From where we have ended, they're telling us determining the speed of the tool. Okay. Determine the speed of the tool. Now you need to remember that speed is a scalar quantity. It's given by magnitude of velocity. Speed equals to magnitude of velocity. So in other words, what we have here is what we are going to get the magnitude. So members, can you get the magnitude, everyone? So you just get the magnitude, 1.5794 squared plus negative 1.8815. Oh, this one I'm going to write it on a bigger screen. There is something I have to show you. Okay, good. So members, you let me know which speed you are getting. Place your calc, place your calc. Members, remember for magnitude, you'll never get an answer. 0. Sorry, not 0. You will never get a negative for magnitude. Your magnitude should always be positive. So can we get the magnitude? Place your calc, place your calc. Yeah. Shiba 2.456. Sammy 2.45, 2.5. Melissa, Jonathan. Okay. I'm going to just copy one answer, 2.4565, and this is your speed, and this is going to be centimeters per second. That means that this machine can each 2.4565 centimeters per second. Dr. P, Samsung, Jonah, MC. Okay. Yeah, those answers are correct, members. Those answers are correct. Yes, those answers are correct. Now, the most important one is now the direction. When you are dealing with the direction, yes, Manuela, let me first pause. Manuela?
So, sir, if they had said vector only, would you have done differentiation by chain rule? Is it correct?
Come again.
On part A, if they had said that find the vector, find the velocity, not the velocity vector. Is it okay if you use dy dx, use chain rule after finding vx and vy?
Okay, now that one, it would have been incomplete because when they ask for a vector and you just find that one, you end up with a scalar.
No, I'm saying when they just ask for the velocity.
When they ask for velocity, still you have to use the same approach because velocity is a vector quantity. So you're using the chain rule of saying dy dx is equal to dx dy dt times dx dt. You end up getting a vector because a vector times a vector, you end up with a scalar.
Okay.
Okay. Now the direction. Now I'm going to draw here for that direction. Now when I have a direction, this is our velocity. When you look at 1.57, remember this is our I and this is J. 1.57 is here, it is positive. J is negative, it is somewhere here. This is negative 1.8815. So when I sketch, our velocity will look like this. This will be our velocity, which I'm calling V. Now, the angle you're going to obtain is the angle here. Hope you are noticing that. So to get this angle, here you have 1.5794. Here vertically, you are going to allow me to remove this now because I've showed you already. Here you have your 1.8815. Why? This negative, like when you sketch, it is showing you in which quadrant is your angle. That's in simple terms. So in order for us to get, we should know that this is the opposite and this is the adjacent. So I use TOA, which means that we shall say that tan of theta is equal to opposite, which is 1.8815, divided by the adjacent, which is 1.794. So what do we get? We get our theta equals to tan inverse of 1.8815 divided by 1.794. So what are we going to end up with? You place your calculator. 1.8815 divided by 1.5794, and then you have a tan of that. Members, you are going to notice that our theta is going to be 49.9886. which you can approximate to 50 degrees. Please take note. I am going to have two things here. The second one, I know some of you are also used to saying that tan inverse is equal to, since this was negative, you could as well say 1.8815 divided by 1.5794. Now, when you do like this, your angle is going to be negative 1.8815 divided by 1.5794, and arctan of that. What do you get? Hey, I want someone to tell us what you get there. I don't know whether I'm getting the same things. What do you get? Remember here we are finding the angle. So I don't expect your calc to be in radians because you get a wrong answer. Shiba said is getting negative 49.9886 degrees. Now, when you look here, this answer you have obtained, is not going to be correct because you may fail to interpret this. Why? Now, why have you failed? The negative will show you the quadrant where tan is negative. So tan is negative. Remember, this is all S, T, and this is C. So tan is negative in this quadrant, and tan is negative in this quadrant. Now, for the best interpretation, we can have this direction stated in two ways. The first way is you stating that the direction is approximately 50 degrees below. When you look at this axis, this is the x-axis. You can say that it is 50 degrees below the positive horizontal. Take note of that. That the direction of my velocity is 50 degrees below the positive horizontal axis. Alternatively, someone can come and say, when we are stating angles, always we measure them in this anti-clockwise direction, and always we measure from the positive x-axis, and we come like this. So the angle we have here is going to be 360 minus 50. So when you say 360 minus 50, we end up with 310 degrees. Alternatively, someone can say that my direction is 310 degrees. The moment you state that one, you don't need to add on any other accompaniment, because any angle you give here, our assumption is always you have measured from the positive x-axis and you have taken the anti-clockwise direction. Hope that is okay. The same concept will apply. I don't know whether you have looked at resolving what. Yes, Ruth.
So sorry for interrupting, but as I think, okay, there's this where we use at school, taught in Mekan, we use what? Okay, yes. Now that this is 50 and it's moving, it's going like in the negative direction. Okay, it's going downwards. So our direction, we don't stop at saying theta is approximately 50 degrees. We say it's east 50 degrees to the south.
That is very okay. So this is east. You can as well, if you don't use below the positive x-axis, you can as well say east 50 south. That is very okay. Okay, thank you, Ruth. Yes, any of those ways is very okay. 50, or say 310. Someone who mentions 310, that one is automatical. We are using that direction. Or you can mention your direction as east 50 degrees towards the south. That's very okay. Yeah. Whether also someone can say south, then you get for us the other angle. That one is also okay. Yeah. Yes, please, doctor.
Yeah, I have a query about that.
Okay.
I thought when we're reading the bearings. When you're reading bearing, we take so I think we get angle and that middle line, the vector.
I've not gotten you well. I'm still confused. Come again.
Okay, so I thought that when you're reading bearing, we begin with either south or north. Then it's always follow next. So I thought that if you're presenting approach, suppose that angle, that angle be that is 90 minus 50. So we get 40. Then we south 40 degrees.
Okay, now, what you are saying is okay, Dr. Peace. Now, when you are stating, or when you are reading bearings, as long as you have started with a major compass point, it is okay. Always, the first letter in bearings shows you the starting point where you are going to start measuring from. So this one means that we are going to start from east. We are going to turn 50 degrees towards the south. But also someone who starts from south and says south, here this is 40 degrees towards the east, can as well be fine. What is very important is that what direction have you started with and what have you ended with? So here we recommend that as long as someone has started with the major direction, it is very okay. It's not a mandatory that you must always start from north and south. I don't know the piece is okay. Is that fine? Okay, I'm going to take an assumption. Okay, so members, that's how you had to deal with that situation. May I know whether we have still some energy or we can? What if we use the cosine rule? Here, once you use the cosine rule, you can get the answer. No problem, Dr. Peace. But that is a length approach. That's a length approach, but you can still get the answer. So allow me to, I don't know whether the energy levels are going high or, in fact, let me just check. Okay, I'm not saying that our time is up. Our time is up, though I had quite a number of scenarios. I know the energy levels have gone low, but I think let me just display such that we try out in our free time. I have another one there. In your free time, because also this one can take us approximately more 30 minutes. This one here. But in case you have energy, you can tell me that let's do it. But if you think we can end the call here such that you can tell me in the chat, you can say we do it or we continue, we shall do it later on. I'm going to just check how many percent we do it. Okay, people are suggesting we do it. Okay, okay. I'm saying people are suggesting we do it. We do it. So members, we are going to do it. We are going to do it. But I think I'm going to move at a speed that is a bit balanced. Now, when you look here, they are telling us that the distance of a particle from a fixed point O is given by this. Show that the velocity v and acceleration are given by this. Now, members, take note. There are two things they can bring for you. They can bring things of show, they can bring things of proving. Now, when they bring for you show, they're asking you, you derive something from the first principles. How did that thing come about? That's what they want us. In other words, they want us to move from here to come and tell them that actually we are also getting that. That's what we are going to do. They have given us the displacement, they have given us the distance, and they want us to show whether actually we are getting this. Now here, we are going to apply different trigonometric identities to see that we come up with that. And always, whenever you are deriving these things, have a mathematical eye, have that end, like see where you are heading, that there are some squared things, there are some squared things. So we continue in that. So what are we going to do? You are going to allow me to first write our displacement. Allow me, I want to just write it here. 3 cos of 2t plus 4 sine of 2t. And what are we showing? We are showing v squared plus 4s squared is equal to 100. So allow me to display a clear screen here such that I can start on a fresh page, and also I have big space of working out. So I'm going to divide my board. So we have our S equals to 3 cos of 2t plus 4 sine of 2t. Now, they told us that V represents velocity. So that means that the first thing we are going to obtain is our velocity. And we know that velocity means the change in displacement with respect to time. So that means we are going to first differentiate. Can I have someone differentiate for us this? Raise up your hand and then you differentiate for us this. Who is, okay, Melissa is, okay, Melissa.
-6 sine 2t.
-6 sine of 2t.
Plus 8 cos 2t.
Plus 8 cos of 2t. Thank you, Melissa. So, members, that's what you get when you differentiate. Now, the next thing you are going to ask yourself, I always have that mathematical eye, that where am I heading? I must have a v squared, I must have an s squared. This is v. Now, members, what are we going to do? In case I have v is equal to 2s and I want a squared, it means that what I'm going to do, I'm going to square this side, I also square that side, such that I end up with a v squared. That is the concept we are going to apply. So what am I going to do here? I'm going to say now, squaring. Okay, allow me to change this pen, and I say squaring both sides. So when I square, I'll have v squared is equal to negative sine of 2t plus 8 cos of 2t, but everything squared. Once you square both sides, you have not changed anything. Members, are we still together up to that point? Let me know through the chat because we must move together. Gilbert says yes. Gilbert says yes. Okay, people are saying yes. People are saying yes. Now, drive. Okay. Now, would you allow me that we expand this part here? Now, I'm going to expand it a bit, but okay. So this will be v squared is equal to -6 sine of 2t plus 8 cos of 2t into -6 sine of 2t plus 8 cos of 2t. Then what you do, you open your brackets very well. You know how we are opening our brackets. You open this multiplies the whole of this. This multiplies the whole of this. Okay, cool. Do you want to open for us?
Good afternoon, sir.
Good afternoon.
Good afternoon, sir.
Good afternoon,
Miss,
cool.
I'm very sorry for that question, but I have a question.
Yes.
Good afternoon, sir.
Yes,
Mister,
go on, I'm
sorry, but I
hearing.
have a question.
Yes, please, go on.
Okay, Mister, The question is how to differentiate that thing to negative 6 sine 2t. I
Were
thought
you
we are
able
going
to
to use
attend the other
the...
lesson we had last week?
No, sir.
No, eh?
Yes, sir.
Oh, I'm not getting you. Members, the rest, let's go on and expand this. Go on and expand this. Yes, you are saying cool?
Miss, I did not attend the lesson.
Have you been able to learn how to differentiate trigonometric functions? Or this is your first
Yes, so
lesson?
far I know how to differentiate like... Mister, what I know is how to differentiate like cos. When I differentiate cos, I get negative sign. When I differentiate sine, I get cos.
Do you know the chain rule? Do you know the chain rule?
Chain rule. Act rule.
Yes? Because what we do here, you let,
I know the
you
product rule.
oh, now, when you differentiate for me 2t, what do you have? du dt. What shall we have?
I get 2.
Now I have y is equal to 3 cos of u. Differentiate for me, what is our dy du here?
I get negative sine u.
But 3, there is a 3 here. So
Yes, sir.
now product rule will tell us that sine rule will be chain rule dy du times du dt. So our dy du is negative 3 sine u, then times du dt, which we obtain as 2. So negative 3 times 2 gives you negative 6 sine of u. But this u, we equated it to 2t. So we shall have negative 6 sine of 2t. So that's how we get it.
Thank you, sir.
Okay. 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 Yes, Dr. Peace. Dr. Peace. Dr. Peace, your network is not so clear. I don't know whether. Yes, Dr. Peace.
Since I was like,
Yes.
I guess something about it that people have finished. I guess.
Hey, people have finished, eh?
I just wanted to point out.
Okay. I'm not getting you. You are saying? Oh, I think. Okay. I'm not getting Dr. Peace. But let me take an assumption that people are there. Oh, Peace, I'm not getting you. Peace, I'm not getting you. Okay. Can we have someone to open for us from there? Dr. Peace, I don't know that you can try to sketch around home where the network could be okay. Okay, let me first mute you and we see whether. Okay, yes, Ruth.
Okay, so we open the brackets. We have okay, I don't know if I should go step by step or I get okay, there's a step 36 sine squared 2t
36 sine
sine
squared 2t.
minus 96 sine 2t cos 2t
Minus 96 sine.
sine
Okay.
cos, then plus 64 cos squared 2t.
Okay, good. I know you have jumped a step, but it's okay.
And I simplified this 96 sine 2t cos 2t. I saw that it's an identity. So I don't know if it will help me get the answer, but I simplified it. So I have 36 sine 2 squared 2t minus 48 sine 4t plus 64
cos squared. Okay, good. I'm going to come at that, but that is okay, Ruth. That is very okay. That's very okay. That is very okay. Hope people have seen that identity. She has applied that identity of Ruth. Hope you mentioned sine 40, right? Let me quote you well. Did you mention that? Yes, Ruth. Did you mention 40? Sine 40. Was it sine 40?
Yes.
Okay, perfect. Okay, Can we go on now, everyone, and also we square S as I pick on SAC? Yes, SAC. SAC. Okay, SAC, I'm failing to get you. So this is our S. So we are also going to square. I've told you always be very mindful where you are heading. There is S squared. So check out how to create S squared. So this will be S squared is equal to 3 cos of 2t plus 4 sine of 2t, everything squared. So let's expand. But could you allow me to jump today like a step? I don't know that I could jump a step today such that our work can fit. I wanted to jump a step, but open your brackets. I want someone who's going to give us that final answer when we have jumped this step of expanding and they give us our S squared. Someone, Sak, I don't know they are giving us that step. Okay, Sak, I'm failing to get you. Okay. Yes, Abu?
Yes, so when we expand, we will have 3 squared, that is 9.
Okay, 9.
9 cos squared 2t. Plus 16.
Plus
16.
Okay, 16.
Sine squared 2t.
Sine squared 2t. Plus
3 times 4. That is 24.
24.
Cos 2t.
Cos 2t.
Sine 2t.
Sine 2t. Thank you. Thank you. Thank you. Good. Someone was saying it is supposed to be 48. Let me hope the person noticed that Ruth jumped up the step. Shadow, hope that is okay. 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 If you can, please expand using your shortcut. Techno, you want to say something? Techno Spark. Kindly unmute. Techno Spark, unmute. Yes, Techno Spark.
Yeah, good afternoon, sir.
Good afternoon.
Actually, it is my first lesson today. The last week I did not attend the lesson. But then, from the brackets, after the brackets, there is this step where I don't know the student's name, but she has expanded. But then I've not understood where she got the 96 from.
Okay, you stay on Tekino. Tekino. When you multiply this, what do you get? This to this and this.
I get 36 sine squared.
36 sine squared.
Yeah. But then
Now get this times this.
Okay. Did I put the negative sign too?
Yes. Yes.
I get negative 48.
48, eh? Cos 2t sine 2t, right?
Yeah.
Then when we come this side, this times this, what do you get?
Still I'll get 40. Yeah. I understand where it comes from. Adding.
Okay. Right. Now, we are going to come here with the mathematical I, members. We are going to come here with the mathematical I. I'm going to write the first equation of V, but allow me, I'm going to arrange it in form of sine and cos first. So I have V squared is equal to 36 sine squared 2t plus 64 cos squared 2t. Hope members are saying minus 96 sine 2t cos of 2t. Now, for Ruth, this one, as well write it in terms of an identity. Now, members, I want you to look at where we are heading. I want you to look at this equation and this equation. I want you to start comparing. Here there is 36, here there is 9. Here there is 16, here there is 64. We have 24, we have 96. What can we do such that here we bring in the identity? The identity now I want you to look at is the identity that sine squared t plus cos squared t is equal to 1. I want you to check out, if I want to form 36 here, what can we do? If I want to get 64, what can I do here? If I want to get 96, what can I do? In the chat quickly, who has seen that? Hey, there is something we need to do. Quick one. Look at those two equations. Hey, another, perfect. People have already seen, I've seen the thing. Hey, I saw someone's hand up. Jonathan, I saw your hand up. I don't know that. Jonathan said, good members.
Yes,
So,
I was saying that multiply times.
Jonathan, go on and tell us now our new equation for this one. How will it be? It will be? Oh. So members, hope you agree that we are going to multiply this by 4 throughout. So we shall have 4s squared is equal to 36 squared cos squared 2t plus, when I multiply 16 times 4, we shall have 64 sine squared 2t plus 24 times 4, which is 96 cos 2t sine 2t. Members, what are we going to do to these two equations if we want to get here? Who has seen what we are going to do? Melissa has already said add V and S. Add V. Members, are you seeing the addition coming in? So we are going to add. We are going to add these two equations. So when I add from on my left, I'll have V squared plus 4S squared equals to, here I want to jump some steps. Look at these two members. I have 36 sine squared 2t plus 36 cos squared 2t. Members in the chat, which answer do we get? 36 sine squared 2t plus 36 cos squared 2t. What do we get? Very good. People are saying the 36. Perfect. There is a 36 there. There is a 36. Very good. So I'm going to bring here 36 plus, what about 64 cos squared t plus 64 sine squared t? Those who are not visualizing it, factorize out the 36. When you factorize out, you get sine squared 2t plus cos squared 2t. So sine squared t plus cos squared t is 1. So you get 36 times 1, which is 36. So that's where members are getting it. Members, are you seeing 64 there? Let me hope now the number comes out the way we want it. So here I'm seeing, for me, I'm seeing 64, and therefore we shall have v squared plus 4 squared equals to 100. Negative 96 plus 96 gives us a 0. Hope it is okay now to everyone. Members, are we good there? Are we good? Are we good? Steve Harrison says yes. So that is how you show, step by step, derive from the first steps, like from the first principles, how things come about, Okay, let me pick on Edith. Yes, Edith.
Yes, on this one, where we have added squared plus 4x squared, here on it is sine 36 sine squared 2t, then plus 36 squared 2t. I've seen that we have 36. How?
Okay, you stay on, Mbuga. Mbuga, you remind us. Mbuga, are you there?
Yes.
Mbuga, what is sine squared t plus cos squared t equaling 2?
Is equal to 1.
1, very good. Mbuga, what is sine squared 2t plus cos squared 2t equaling 2?
It will be equal to 1.
Be confident. What will it be equal to?
I think it is 1.
Okay, just say it is 1. No matter, Mbuga, which angle we have here, even if I have sine squared 1000 plus cos squared 1000, what do we have as our answer, Mbuga?
1.
1, very good. So the angle, as long as these two angles are the same and you are squaring, your answer is always 1.
1.
True?
Yes.
Now, Mbuga, I have 2 sine squared t plus 2 cos squared t. What is common here and here?
It is 2.
2. So when we factor out t, Mbuga, what do we remain with?
We remain with the 1.
1,
as in squared t plus cos squared t.
And you know that one is equal to what?
To 1. 2 times 1.
Which
Get
is?
2.
Are you seeing where 36 is coming from?
Yes.
Okay. So that's how it came about.
Thank you, sir.
All right. So members, I'm going to go back a bit, one step, and now we look at the second part. The second part wanted us to show that a plus 4s is equal to 0. Cool. First ask, as members also try to figure out that. Okay, cool has disappeared. So, cool.
Mister.
Yes.
Excuse me.
Yes.
Mister, I have a question where we introduced the other identity for sine squared, cos squared. When we are expanding the equation, why have we multiplied the by 4?
By 4. Now, you look at where you are heading, where we are heading. That our proof, our number they wanted us to show had a 4. Are you seeing that there was a 4 here? Now you ask yourself, how can we bring that 4 there? Since we had s, how can we bring a 4 there? That is gotten by multiplying by 4. So now you need to look ahead where you are heading and what you are supposed to come up with. I don't know that is okay. Is it fine?
Yes, sir.
Okay. Now I'm going to go back a step. 96 Collins, when you add these two, negative 96 plus 96 is 0. And these two things are the same. It's like having negative 96x plus 96x. So this is 0. So that's why we have 0. Okay. Now I go back a step. So we are going to show for the second part. Members, also the second part is not so hard. Also, we follow the same. Remember, I want to remind you that we had our S as 3 cos 2t plus 4 sine of 2t. We went on and obtained our V as the S dt, which gave us our V as negative 6 sine of 2t plus 8 of cos of 2t. Now, the next is to find the acceleration, because they told you A is the acceleration. So we know that acceleration is given by the V dt. So members, can we have someone to differentiate for us, to get for us what our acceleration is equal to? Anyone ready? Okay, Aren Dorin.
Our acceleration is equal to negative, it's equals to negative 12 cos 2t plus
Come again
negative,
there.
Minus
Uh-huh.
negative 16 sine 2t.
Sine 2t. Very good. Now, members, I want us to look ahead. Doreen, don't run away. Stay there. Are you still there, Doreen? Doreen, come back, small. Where is Doreen? Doreen, have your hand up again. Okay, I want someone. Okay, Doreen is back. Yes, Doreen, unmute.
Yes.
Now, Doreen, I want us to look. Are you seeing where we are heading?
Yes.
I want you to look here, Doreen. Are you seeing there?
Yes.
How can we bring in an S at that point?
An S at that point?
Hmm.
I'm not sure.
Look again. What is similar in S and it's similar here? We start from there.
Cos 2t.
Cos 2t, good. What else?
And then t.
And
then sine 2t.
very good. We are going again. Doreen, what is common here and is also common here?
4.
4, good. What else?
Negative 4.
Negative 4. Let's factorize it out. I'll factorize it out. What do we remain with?
We remain with 3 cos 2 plus 4 sine t.
4 sine. What are you observing now, Doreen?
I'm observing that the values in the bracket for that are the same as the displacement is.
Very good. It's the same as the displacement. Take us, continue. So what shall we have? A is equal to?
Negative 4s.
Continue.
And then I think you divide negative 4 on both sides.
Are we safe, Doreen?
No.
Look at where we are heading.
Yes, I've seen. I think I'm not sure.
Doreen, come again. How do you think we can reach here? Look at where we are heading.
Maybe we take the what? The negative 4s the other side. Comes positive 4s.
Okay, so what shall we have?
A plus 4s equals to 0.
Equals to 0. Okay, thank you, Doreen. So members here, don't forget by saying that but S is equal to 3 cos of 2t plus 4 sine of 2t. Yeah. So members, let me know through the chat whether we are there. Whether we are there. Are we on the same page? Okay, people are saying, yeah, we are there. Okay, good. Now, remember, hope members know that we have not yet even attempted part A and part B. Yes. Now, part A. Part A is requesting us to find the greatest distance of the particle from O. The greatest distance of the particle from point O. Now, this is where you need to know some kind of, in case when you look at this, one thing that should come into your mind, is one, let me ask you, I'm going to just draw here. One, when you look at this, members, you notice that that is a quadratic curve. And please do not forget, once they say hence, they want you to start from those previous answers you obtained to continue. Now, when they ask us the greatest distance of the particle from point, when you look at this one, you notice that this one is a quadratic curve. And if I can write it in a way that you may understand, okay, which way can I write it? Okay, you notice that curve can look like a bit like that. Let me put it just like that to make your life a bit much easier. Something like this, but you'll notice it can look a bit like that. Now, when you look at it very well, you are going to ask yourself, when the particle is at its greatest distance, it means that is, like when you kick the ball, let me use the ball. When you kick the ball, the greatest distance the ball can reach is this maximum point, and then it comes back down. Now, members, when you reach your greatest point here, what do you know about the velocity? In the chat, what do you know about the velocity at that point? Bettina, thank you, the maximum point. Wafla says, people are saying the velocity is 0. Thank you. The velocity is 0. Because what happens that here, when you reach the maximum, remember your velocity, when I try to draw velocity against time, I'm just using this to explain the concept, but here we don't have time. That when you reach your greatest point, you start with like you know, when you are running in the field, you start with a lot of energy. By the time you finish, you'll notice that your speed, your velocity has reduced. That is the same thing that happens. That the moment you reach your maximum, your velocity comes to 0 because it goes on increasing. The moment you reach 0, then you start going down. So at this maximum, at that maximum point, our velocity is going to be 0. Now, the moment the velocity is 0, we are going to ask ourselves, what is that point? So now we are going to come for part A, members, and say for part A, at the greatest distance, V is equal to 0. Now, members, can you get the maximum displacement S? Where there is V, put 0 and tell us what are you getting for your S. Someone can even take us through here. Anyone who wants to take us through? Yes, S.6.
Good evening, sir.
Good evening.
So, like, the thing is, 4a squared equals 100.
Okay. 4a squared is equal to 100. Good.
100 divided by 4, which is 25.
Okay, s squared is equal to 25.
So you square root both sides and get s equals to 5.
S is equal to 5. Okay, thank you. And what are the units? Do you know the units or they didn't give us?
They didn't give us.
Okay. Okay. So you end at that point. Here, I know people are going to ask, but why not positive and negative? Why positive not positive, not negative? I know people are asking why? Eh, I don't know whether people know why. Okay, I know people are thinking why. But I'll tell you at one point. Though I showed you how that curve looks like. I showed you how that curve looks like. Those curves there. But I'll show you at a later point. Okay, I'll show you at okay, displacement can't be shadow displacement can be negative. Displacement can be negative, but distance cannot be negative. Thank you. It does not require direction. Very good. So distance is always positive. Distance is always positive. It can't be negative. But if they had asked maybe displacement, that's when you can even consider the direction. Okay. So hope that is okay. Then for the second part, the acceleration at this instant. What is the acceleration? So in other words, your curve, in case this is your curve, the distance from here up to here, it will be 5. So what about the acceleration? Then we come here. We know very well that for part B, acceleration plus 4s is equal to 0. So where there is s, put 5 and find what is your acceleration. Where there is s, put 5 and then tell us what your very good. Anyone to offer to us an explanation for that? Okay. So someone I saw in the chat, someone was asking, sir, repeat something about velocity is equal to 0. Now, sometimes, many times, when you throw a stone up, like you have thrown your stone up, it goes, it will come back. Why? Once it reaches the maximum height, it stops moving and it comes back. So stopping to move, it means that your velocity, your speed comes to 0 and then you come back. Because why does it come back? Because of acceleration due to gravity. That the moment you throw an object up, it reaches a point, momentarily it stops and then it comes back downwards. So at that point when it stops and comes back, that's when we say that it has reached its maximum and it has come back. And I know so that's why always whenever you throw something up, it will always come back. It doesn't matter. So the moment it reaches where its speed has reached 0, it comes back. So gravity pulls it back down. I think it is only Jesus that was never put. No, it's not only Jesus. I know there's another person who went up and never came back. Yes, but for we know that the moment you go up, you'll come back. And why is it negative? Because now the particle is coming downwards. Yes, so deceleration is very okay. It is retarding. Perfect. Yes, members, that is very, very correct. Even Mother Mary, I don't know. Even Superman. Okay, yeah, I think also some of those people. Okay, members, why don't I give you some exercise that you are going to try out in your free time? In your free time. In your free time. In your free time. Just take a screenshot of those two as I answer Mbuga. As I answer Mbuga. Yes, Mbuga.
Master.
Yes.
So if they pass units, we just leave it like that.
Yes, Mbuga, that is correct. The moment they don't, leave it. Don't commit yourself. Though I know in some books they can put units, but there is no need because you are not sure.
Okay.
Okay, hope members have taken a screenshot of the numbers they are going to try out. Yeah, I can give you another one here to try this one as well in your free time. Okay, I think those ones will be enough for today, those three numbers. But in case you want to get more challenging ones, let me see. Those who have this pure math, this back house, you can come and try out some numbers here in exercise 19A. In fact, some of those numbers, I picked them from here. I picked a number, now like number 6. I picked it, one of the numbers we did, I picked it from here. Then another number I picked from here is number 7. When you look at number 7, I also picked it from here. That scenario we have been doing, I picked it from here from Backhouse. Now this number 5, I know you would love to try it out, but unfortunately for this number 7, they gave you velocity. And once they give you velocity, in case you have not yet done integration of trigonometric functions, you may not be able to find it. But those who have finished integration of trigonometric functions, you can as well do number 5. But here, since they gave us velocity and they want to get distance, we have to integrate. So that one, you may not be able to do it. The same thing happens on number 8. They gave you velocity, so you may not be able to do it. But in case you know how to integrate velocity to get distance, then it is okay. You can continue and do it. But you can try some of these numbers in your free time. Yes. I think we are going to end here for today. We have pushed a lot. So the next time, God willing, when we meet, we shall be looking at other integration of trigonometric functions, and then after that, then we shall still now bring in scenarios again. Okay, otherwise, thank you. Our lessons are still happening early in the morning at 5 a.m. I know some of you might have missed, but we resumed our 5 a.m. lesson. So in case you missed today's lesson, feel free to go back and watch that recording for what? For the morning lesson. So we looked at something today. We looked at angle between lines. Yeah, you can find it, the recording on the YouTube. Otherwise, thank you so much. And I know those who have not yet gone back to the WhatsApp, you can get, let me first stop recording,